Hello student, welcome to the 6th day of online tutorial session. Today's topic is binary adder subtractor. So, or you can say it 4-bit parallel adder subtractor circuit also. Okay. So, what is the function of it? This is a arithmetic micro operations like addition and subtraction can be combined into a one common circuit including an exclusive OR gate with a full adder. Okay. So, here in this circuit we can perform both addition and subtraction. Okay. Both the operations are combined into one circuit. Okay. So, actually, so for that reason we will require three components. First component is required that the full adder circuit and one XOR gate and one the control line. Okay. So, full adder you can understand that using full adder we are actually adding. Okay, but what is the use of the exclusive OR gate? Exclusive OR gate is act like a inverter over here. And why inverter I will explain later on, and one is a control input line. Okay, so control input line is required where if a circuit will act like an additional circuit or act like a subtractional circuit, through this control input we will able to determine. Okay, so first you go through the block diagram of the 4-bit parallel adder subtractor circuit. Okay, this is a block diagram of a 4-bit parallel adder subtractor circuit. Okay, I am talking about the control input signal, that is adder subtractor control line. M is denoted as the adder subtractor control line. Okay, here is the XOR gate is there. Okay, XOR gate will find out the ones complement. Why ones complement is required over here? If you remember that I have explained the topic that using 2's complement method find out the difference between two binary inputs. Okay, so in this method what we are doing, first we have to find out the ones complement of the addend, and next we have to add 1 with it to get the second complement of the addend, and next addend will be added with the augment. Okay, so then only we are getting the difference value between two binary information. So, here also we are doing the same thing. The main thing we are doing what? Addition and complement find out. So, that is in case of addition we require adder, and in case of subtractions also using 2's complement method we are doing addition. So, that is why only here I am using the full adder, not any half subtractor or full subtractor. Okay. And XOR gate, what is the requirement of the XOR gate? XOR gate will find out that ones complement of the addend. Here I am taking two 4-bit information. Okay, the first input is A0, A1, A2, A3, and second information is B0, B1, B2 and B3. Okay, so in second complement using my method, what we will do, first we have to find out the complement of the first information. The first information is A0, A1 and A2, B2 and B3. These are the first information and the second information. So, what we will do, we will find out the second find out the second complement of the B0, B1, B2 and B3. Okay, so that is why you are able to see B0, B1, B2 and B3 both are passing through the XOR gate. Why it is passing? To find out B0 complement, B1 complement, B2 complement and B3 complement. Okay. Through this M control line, if you want to do addition, then we have to pass 1. So, if M control this control signal will get the information as 1 or high voltage, then it will able to understand that through the C0, that is the C in of a full subtractor, we will giving the 1 over here. Then what will happen? Ones complement plus of 1. So, we will get what? Second complement of the B0, B1, B2 and B3. Okay. So, with this second complement, we are adding A0, A1, A2, A3 individually, beat per beat. Okay. So, B's complement, we are getting B's first complement. This first complement with added with 1, that we are getting from the control adder subtractor control unit. So, we will get the second complement. Then second complement is added to the A0. Then second complement is B1 is added to the A1. Second complement is B2 added to the A2. Second complement of B3 is added to the A3. In this way, we are doing the addition and propagating the carry C4, or you can say it is a C out, is our final carry output. Okay, and S0, S1, S2 and S3 for subtraction will give you the difference value for the each bit. So if this circuit, if you want this circuit will act as a binary subtractor, then through this M control line you have to pass 1. Okay, and if you want that the circuit will act like a adder, then what will happen, that through this M control line you have to pass low voltage. Low means 0. If you are then passing 0, then what will happen, XOR gate will not produce the complement of the addend. That is, addend is what, B0, B1, B2, B3. It will not generate B0 bar, B1 bar, B2 bar, B3 bar. Okay, okay, directly it will pass B0, B1, B2 and B3. Okay, then directly over here in the C0 part we are getting what, 0, and directly there is no complement, no formation of the second complement, because if you first complement is coming, then we have to plus 1, but here the signals we are getting what, 0, so no second complement we are getting. So directly B0 and A0 is added, B1 and A1 is added, B2 and A2 added, B3 and A3 added. Okay, and S0 is the addition for the addition root, addition sum, addition whatever output we are getting from S0 for the first bit it, and S1 is the addition result for the second bit, S2 is the third result, and S3 is the fourth one. In this way we are getting the sum output, and C4, or you can say it as C out, is the final carry output for this circuit. So one circuit can act like a adder, one circuit can act like a subtractor. It is depending upon the input through the control input line, whatever you are passing. If you are from the control input line, here is M. If you are passing 0, then it will act as a 4-bit adder circuit, and if you are passing -1, then it will act as a 4-bit subtractor circuit. Okay, actually whatever I have explained, I have just written the content. Okay, whatever I have given, the explanation is given, that is written over here. If this question will come, you can represent like a block diagram, and you can write in the few point, you will get the full marks. Thank you student. I am ending